Hi, we are Team 64, StarkTech. I'm Guillermo Hoffmann.
And I'm Dennis Lee.
We were in charge of simulating a robot using Simulink. The objective of this simulation was to use Simulink to study the robot's movements.
The first part simulates the movement of the wheels. The two joysticks on the gamepad controls two wheels, and each connects to a VEX DC motor. The joysticks take analog values, with positive 127 being forward maximum and negative 127 backward maximum. Since the robot couldn't turn before we built it, we had to simulate its turning as well.
Initially, the robot is located at 0, 0, facing the positive x-axis. If both joysticks push forward, say positive 127, the robot moves forwards. If the left joystick controlling the left wheel is pushed forward, but the right joystick is pushed from front to back, the robot starts to make turns clockwise. The outputs show the torques generated by the two motors when the joysticks are pushed in a certain way, so our field movement simulator illustrates the wheel movement.
The second part simulates the movement of the arm. The two buttons on the right side of the controller control the arm. When the up button is pressed, a digital value positive 1 is generated to move the arm up. When the down button is pressed, a digital value negative 1 is generated to move the arm down. When both buttons are pressed accidentally, neither action occurs.
The DC motor which we used for the arm generates a maximum torque of 9.407, and the maximum rotation speed is 90 RPM. We simulated putting the torque through a compound gearbox, which was a 40:7 ratio. We created a custom function to calculate the torque change to the gears, and we calculated a 6.22 time increase. After we put the torque through the compound gearbox function, we calculated the torque that would output when we pressed the up or down controls.
We used a servo system to adjust the height of the bar shots. We made the right and left servos move with buttons regions 8 and 7 respectively. Buttons 8U and 8D raised and lowered the right servo, while buttons 7U and 7D raised and lowered the left servo. The servos could not move higher because they had a bimodal state, one of being either up or down.
That concludes the simulation overview for our Simulink program.